Okay, so we are still working with equations of planes and lines. Let's bring some planes into it now. So here we're given this plane. This is the general equation of the plane. 6x plus 2y minus z equals to 8. And I want to find the vector equation of the line that passes through this point, 1, negative 2, 5, and is perpendicular to my plane P. So remember that when we're given the general equation, we can look at that equation and find our normal vector being a vector that's perpendicular to the plane. So here, what I have is my plane. Remember we said that sometimes it's useful to draw them as lines. So I have this plane, and I have my normal vector being perpendicular to that plane. So it hits that plane at 90 degrees. Now, what I want is a line, and I want for my line to be perpendicular to that plane. So if I look at this line right here, it's perpendicular to the plane. What's its relationship to that normal vector? Notice it's also parallel to that normal vector. So what we can say here is that my L is perpendicular to P. So that means it is, actually I wanted to do P like this. My L is perpendicular to P, so it is parallel to that normal vector. Now, if we recall, to do the vector equation of a line, I'm gonna need x, y, z is equal to some point. Notice I have a point. That's my point. I'm given my point. My point is 1, negative 2, 5. So I'm given my point, 1, negative 2, 5, plus t. And what I need here is a direction vector. And that direction vector is going to be parallel to my line. Well, do I already have a vector parallel to my line? Yes, it's a vector normal to the plane. So that normal vector is parallel to my line. Therefore, it's the normal vector to the plane, but the direction vector to the line. So it is a direction vector to the line. Okay, which means that I can just stick it in there, 6, 2, negative 1, and voila, that is my answer. Ta-da, it was that simple. So we're gonna have a part B to this question, and that part B is the vector through the points through the points P1, where P1 is, actually we'll just call it, yeah, P1, 1, 0, 1, and Q, negative 2, 3, 4, parallel to this line. Okay, so in order to answer this question, first we need to find the vector through the 2 points. How do we find a vector through the 2 points? Terminal point minus initial point. So the vector through the 2 points, that's going to be P1Q with a little vector sign above it, is Q minus P. So that's negative 2 minus 1, 3 minus 0, 4 minus 1. So this is negative 3, 3, 3. This is the vector between the 2 points. Now, is this vector parallel to this line? Well, if it's parallel to the line, then it will be scalar multiples with the direction vector. Remember, 2 things are parallel if they're scalar multiples. The direction vector is like the slope. So are the slopes the same? Are they scalar multiples? Well, the answer here is no. So here we can just say they are not parallel. It is not parallel because negative 3, 3, 3, and the direction vector of the line the direction vector of the line, which is 6, 2, -1, are not scalar multiples, and thus not parallel. Okay, so we're going to add one last question to this. So basically we're saying 6, 2, -1 is the direction of the line. This vector is a different direction. It's not scalar multiples. Is that different direction perpendicular? So that's our third question here. Is that same vector, which we'll call P1Q, is P1Q perpendicular to the line? And the answer here is, well, that depends on the dot product. Is this vector perpendicular to the direction vector? So to check this, we just need to check the dot product of this with the direction vector. So I'm going to call this vector right here D. So another way of asking this is, is P1Q dot D equal to 0? So P1Q, the vector, dot D is equal to -3, 3, 3, dot 6, 2, -1, which is -3 times 6 plus 3 times 2 plus 3 times -1, which is -18 plus 6 minus 3, which is -15, which does not equal 0. So it is not perpendicular to the direction vector and therefore not perpendicular to the line. Direction vector, and therefore not perpendicular to the line. All right, so in other words, what we are saying is, if I want to know if a vector is parallel to or perpendicular to the line, I just have to compare it to the direction vector. All right, that's all. Next example will really focus on planes.